if the two charges have the same sign, they are gonna repel. So let's say you wanna find the force, right? The vector force, vector electric force at Q free. If you are looking for that, then you are gonna draw the force on Q free due to Q1 like this. We can call that F1. And it's like that because they repel. However, between Q2 and Q3, you have positive 5, negative 6. So there is a force like this. I'm going to call it F2. That force is in this direction on Q3 because they attract. Is that clear?
So the question is saying that F plus phi is acting on them, or they are acting on phi plus.
F1 and F2 are acting on this charge.
Okay.
F1 is due to Q1. F2 is due to Q2.
Okay.
And then you have to find the magnitude of F1. In the first quiz, the confusion was that most of you used the wrong equation. It was asking for the electric field, not the electric force. Here they're asking you for the force, so you use K, because it's F1, K Q1 Q3 over the distance. This distance here is 20. It's 20 centimeters, so 0.2 meters squared. All right. Now, the value of K will be given in the exam, or you're going to have it in the question sheet anyway. But always use this, all right, to make it simple. That times Q1 times Q3 divided by 0.2 squared, which is there. So 9 times 2 times 5 divided by 4. Okay. All right. So let's put that in there. 22.5 times 12 negative 3 times 10 to a negative 1. So 2.25 newtons. Okay. That's F1. So that's this. For F2, you will use the same equation. Q1 doesn't change. Now it's Q2. So divide by the distance. What distance between Q2, Q3, and Q2? All right. Oh, wait. My bad. This should be 5. So I'm looking at Q3 and Q2 for F2. So that and that. 5, 6, 5, 6, yeah. And then the distance is 15, so 0.15 square. Yeah. Okay.
Yes.
Uh, I will check this. I think it's 2 point, yeah, 0.025, of course. So ooh, this is 9 times 5, 45 times 6. What I do here? Okay. So I will do this 45 times 6, 270 times that, and the negative 3 divided by 0.0225. Okay, so that's always going to give you also a little bit bigger than before. That divided by 0.0225. Ooh, all right. Let me see this again. 45 times 6 divided by 0.50 divided by, yeah, that makes sense. And then divide by 1 to 3, yeah, 0.270. Wait, why is it less? Should be more. Let me double check something here. Maybe because it was 218 times, let me just double check these numbers here. 18 times 5 times 5 divided by 0.04 divided by 2 point, yeah, that's fine. This is correct. So
It's
this
a
one was going,
0.04 square,
yeah,
I
just
think.
let me see. It doesn't make sense that it's smaller than that. I was forgetting another zero. There it is, 12 newtons. So it's 12 newtons. It should be 12, right? Why are we
Yes.
using the distance from Q3 instead of Q1? Q3. You're looking at the force at Q3. So F1 uses the distance between Q1 and Q3. F2 uses the distance between Q3 and Q2. So this. That's why. Okay, just be careful with that. So there is 12 newtons here, and there is 2.25 newtons on the right. Right, so the net force, F net, vector-wise, at Q3 will be negative 12 plus 2.25, which will be negative 9.75 newtons in the x direction.
Is 12
Okay?
is 12 negative because it points to the left, right?
Yeah, yeah, yeah.
Mhm.
So if both of the forces are acting on the left, then it's positive or negative net force.
You have to add them. No, left means negative, right means positive. If both of them
Okay,
were
but
pointing towards the left, you have to add. So it will
so
be
we put a minus sign or no minus sign? Means if it's both
minus
of them
12
in.
minus 2. Okay, I think that's what we have to review. More than this, I think you guys have to review. And this is why you guys have to learn vectors. And this comes from high school, guys. Okay, so let's go over this. If you have a point A, and you have a force here, 10 newtons, and you have a force here, 6 newtons. The net force is 4 newtons. That, I don't have to explain why. It's 10 minus 6. However, if you have the force both going to the left, then this is negative 16 newtons. You see what I mean?
Yeah, so if the force goes to the left, it's always gonna carry a negative sign. If the force goes to the right, It always going to carry a positive sign. The only thing we have to do is add them to each other. So in this case, we're going to get
Yeah,
negative
yeah, I
6
think
plus negative 10.
yeah, the issue is that some of you uh were not didn't have that clear when to add, when to subtract. That's why you have to draw these arrows first. And those arrows come from the signs of the charges, right? If they repel, if they attract, and there you are. You have opposite directions, they have to subtract. Now, if if you have a situation like this, there, the net force is 1.75 positive minus 10 newtons, which is negative 8.25. The negative just means that the net force is like this. That's the net force to the left. Make sense?
Yep.
Yep.
Yeah. Okay. Let's do one on circuits. So we're asking there. Yeah, let's do this. I'm just gonna like use yeah, let's ask, we can use this for a couple of questions that I can ask. So you have resistors like that. They tell you the net current and the voltage on the batteries. So what is the value of R? It's more algebra. That's why I will make a variation of this question for later so you can see how to find the equivalent. Although you're going to see that we have to find the equivalent resistance. It's just that you have to find it in terms of R. Okay? So the first thing that I want you guys to have clear is that in resistors, when they are in series, you add them. And then these two in series are in parallel with this. And then all of these three, once you combine them into one, are in series with this. You have to think, you have to realize that first. Once you realize that, you can find the equivalent of these two, which is R plus R to R. And then you have this R there. To R and R. So these two, you can combine them into one like this. 1 over, I'm going to call it R prime, so you get confused, is equal to 1 over 2R plus 1 over R. That, if you multiply by 2, you get 3 over 2R. And don't forget you got just 1 over R prime. So R prime is, when you flip it, is 2R over 3. That's the equivalent of these three. And then you add this to this, which is R plus 2R divided by 3. R over 1 here. 3R, 2R, 5R divided by 3. So this is the equivalent resistance. in terms of R. Now, they give you the current, they give you the voltage, so R equivalent is V over I, which will give you 50 ohms. That 50 is equal to the expression you found up here, 5R divided by 3. Then R, well, if you solve for R, that's equal to 30 ohms. So 30. So you still saw the parallel and series there, but with the variable R. Let's give you a same setup where you guys have to find the current and a few other values here. That's what you need to practice, right? So when I use the same circuit, it's in here. So let's put it here. So let's draw this here. Let's put this away somewhere here. So the circuit is all right. It's basically like this. Remember that for this, you don't really need to know where the positive and negative is. Put it here just so you know, but it's not Kirchhoff's. Okay, so values of resistance, right? Let's make this 2 ohms, 4 ohms, 3 ohms, and 6, 3, 4, 2, 8 ohms. There you are. So you're gonna find the equivalent resistance. Then you're gonna find the current on the circuit I. And then on C, let's just say you wanna find the current at 2 ohms. So how will you do a problem like that?
At 2 and 4.
Yeah, I want you guys to try and do it, and then we go over the
Oh, okay.
solution. I'll give you like what, 3 minutes for this? I shouldn't take more than that. If you have the answers, you can start typing them on the chat and see how they compare with other students. Mm. Okay, so the equivalent resistance is 10 ohms. And I'm pretty sure some of you need clarification because I see only a couple of students got it so far. And then the current is obviously 1 ohm. I mean, 1 ampere. Okay, so these two are combined. I kind of already show it with a previous example, right? It's the same setup. You add these two into 6 ohms. And then you have this and this in parallel. So 1 over R equals to 1 over 6 plus 1 over 3. If you have two fractions, the R of this 3 is 6 times 3 over 6 plus 3. It's 18 divided by 9, 2 ohms. Now this is in series with this. So the equivalent is 2 plus 8, 10 ohms. How do I get 1 ampere? I is V divided by R. That's how you get 1 ampere. 10 volts divided by 10. Anybody got the current on 2? What's the current on 2 amperes? It cannot be 5 if your total current is 1. 1.66. It cannot be greater than 1 because the total current is 1. It has to be less than 1. The current on this junction splits. Anybody else? There's another answer here. Let's see. 5? No, it's not 5. Yeah, you're dividing 10 by 2. 2 divided by 10? No, it's not 0.2. It's actually 1 times 2. 2 divided by 6. Yeah, it's 2 divided by 6. So 1 over 3. So 0.33. It's 0.33. The reason is because the current is split, so you cannot use 10 divided by 2 or 10 divided by 3. This voltage does not apply here. And I said this in class, there is a resistor outside. If there was no 8, yes, it would be 10 divided by 3, the current here, and 10 divided by 6, the current here. But there is a 8. That changes everything. That's why, luckily, I found this so you guys can see how it's done. You need to find the voltage on this branch. If the current is 1 ampere and the resistance of this branch, 2, 4, and 3, is 2 ohms, that's why you have to keep this there, then the voltage at 2, the voltage at the branch, let's call it like that, branch, that is 1 times 2. So 2 volts. Again, this is the branch, okay? It's like a small circuit inside another circuit. Now, the current at 2 is the voltage through these two, which is 2 volts because it's in parallel, divided by the total resistance between these two, which is 6, which is 1 over 3, which is 0.33 amperes. All right? That's how you do problems like this. Any questions? So that's your parallel and series there. And actually have this as well. So let's analyze this problem. Similar. Now you're going to find the equivalent capacitance. For B, you're going to find the total charge. And for C, you're going to find the there. I think that's fair. Let's see. This is now a capacitor circuit. Very similar to the one that you just did. Think about it. It's just a different, how will you say? It's a different setup, but it's identical if you think about it, like in the way of thinking. All right. What's the answer for part A? Maybe 17.2. Yeah. Yeah, 17.2. Yeah, that's good. Okay, so do I need to explain that, or is that clear for everybody that C equivalent is 17.2? So for capacitors, it's the opposite. Again, as I said, it's very similar to the previous with the resistors. These two are in series and then in parallel with 100. So when you have capacitors in series, you don't add them. You do for these two, right? 1 over C equals to 1 over 60 plus 1 over 40. And I was just doing the calculator here. This will be 60 times 40, only because it's two fractions, huh? Divided by 60 plus 40, which is 100. So the equivalent of these two is 24 microfarads. And then this one and these ones are in parallel. So all of these three, you add this and this, is 124 microfarads. You add them in parallel. Important that we have this here, okay? All this branch again is this. And then it's in series with this. So the equivalent capacitance, or 1 over CQ, is 1 over 124 plus 1 over 20. Which, this times that, divided by this times that. So that gives you this. All right? Any questions about that?
No.
Okay. What is the total charge on the circuit then? Yeah, you just multiply, right? Q equals to CV, C equivalent times V. V is 10 volts. This times that is 172 microcoulombs. So part A and part B should be clear. How do you find the charge? Sorry, part B here. How do you find the charge at 20 and at 60?
We have to find the voltage first, right?
Well, for the charge at 20, you don't have to do anything. What's the charge at 20? You guys need to be careful though.
172.
Yeah, you cannot have more than 172. 172 microcoulombs is the
Of
total
Professor,
charge. So
the
it's 172. It's 172 microcoulombs.
so
Because
Q is constant in a series, right? Charge is constant in a series,
yeah,
and voltage is constant in a parallel
yeah,
for the
yep.
capacitance.
Yep.
Okay.
All right. So that's the charge at 20. Now, what about the charge at 60? Now you have to go backwards a little bit. Okay, let's check. Let's check. So Q divided by C, that's V times I get 33.29 divided by yeah, 124 is about is a capacitor. That's V is times 100. Yeah, 138 minus 172. Yeah. Okay, yeah, it's about 33 microcoulombs. This charge is the charge on 20, but it's also the charge at this 124. 124 is a combination of 60, 40, and 100. All right? So when you divide 172 by 124, you're getting the voltage on this branch, which makes sense. It's basically 1.4. Let's use this number there. That's the voltage in here. Now, if I multiply the voltage times 100, that's the charge on 100, 138.7. So then I subtract 172 minus that number there. Well, this number, 33.29, that's the charge through here on this. But because it's in series, the charge on 40 is the same as the charge on 60. So that's the charge. 33.29 is the charge on 60 micro.
And it's going to be the same charge on 40, right?
Yeah.
We can also do 24 into 1.38, right?
Yeah, that should work, right? Let me see. That's the voltage times, yeah. Then you do that and then it works. Yeah, you can do that. CV. Q equals to CV. So, yep.
Could you please explain how do we measure the voltage on the parallel?
Just divide the charge over the equivalent capacitance. Well, the capacitance of this free, which that's why I said you have to write those down. Like the capacitance of this free is 124. So Q over C, Q over C is V here in the equation for charge, capacitance, and voltage.
So we divide 172 by 124, right? That's where we get 1.38.
Yeah,
And
exactly.
1.38 volts is going to be on 60, on 40, and on 100.
1.38 will be on 100, and 1.38 will be on the combination of 60 and 40, which is 24. Which is why you can multiply 24 times 1.38. That's the total charge on 60 and 40. Now, the charge is constant because they're in series. The voltage splits up.
So,
So if
so
you
the
want to
rest
find
voltage,
the voltage
sorry.
on 40, for example, will be 33.29. That's Q divided by 40. That's the voltage on 40, 0.83.
And what is 33.29?
That was the charge on 60 and 40. Right? You just divide. We did this to find the voltage on the branch and multiply by 24, and that was the charge on 60 and 40, which is also, well, is a charge on 24, which is a charge on 60, which is a charge on 40.
Hmm.
Okay?
And
The main thing,
if we want to
yeah,
find the voltage on the 20 microfarad capacitor, then we divide 172 by 20.
yeah,
Okay,
that's it. Mhm.
thank you.
Any other questions about this? All right. Ooh, how many? How will you use this problem here? You have a parallel plate capacitor and you're given the distance between the plates, the area, the voltage. You're being asked for the value of C, the capacitance, the electric field. If you introduce a dielectric, what's the value of the dielectric strength? How will you do that?
First, we have to convert 5 centimeters to meters.
Mm-hmm.
0.005 meters.
Mm-hmm.
Um,
It's C equals to EA by D equation.
E naught area over distance, yeah. And once you have C, you can find, well, you don't need C for E, but you know the equation for electric field for this. Okay, let's say, what was D in meters? 0.05, right? What's the area in meters squared though? You're giving 80 millimeters squared.
10 raised to minus 6.
So this, is that clear for everybody? Why 10 to a negative 6?
No.
Huh?
No.
No? You divide by 1,000 twice. There's 1,000 millimeters in 1 meter. And because it's a square, you divide by 1,000 twice.
Okay. Now it's clear.
Okay. So that's that. So in note, you have in your notes, is this constant in vacuum, area, oh, it's very small, over distance. Okay, what's the answer?
It's 14.16 into 10 raised to minus 15.
Yeah. Farads. Farads. Increíble that.
Professor,
Yeah,
could you please remind what chapter this formula is from? The C equals E naught A divided by D?
that's chapter 16.
16. Thank you.
Yeah. What about B? How do you find the electric field?
Delta V divided by D?
Yeah, or V over D, right?
Mhm.
We don't worry about the negative in this case. So 25 over 0.05, which I believe is 500 volts per meter, right?
Yes.
500.
Huh?
Yes, 500.
Volts per meter. All right, so we did this. If you introduce a dielectric, what's the value of the dielectric strength? How do you find this? Anybody? Come on, that's a simple,
E by K.
yeah. E divided by the small k, which is the dielectric constant, which is given here, 2.1. So 500 over 2.1. That's what, 250? 249.9 maybe? 49 point something. Right there. Volts per meter as well. Okay? There you are. It's capacitance. And then what about this? So you have a proton at rest in this electric potential. Find the speed due to delta V. It's a proton, so You need this. And you need this. All right, go for it. Let's see how you do that. For students doing the lab, you just stay on this call. I'm gonna send this link to the other Canvas lab shell, okay? So they can join. We still have time though.
We use conservation of energy.
Yeah, yeah. Did you get a value for V? Mm. Oh, wait. So, anybody?
Isn't delta U equals negative kinetic energy?
Uh, Technically, but basically it's like your conservation of energy that you did in mechanics. So energy lost equals to energy gain. So
Okay.
the energy lost due to the electric potential, yeah, is gained by kinetic energy. So you can just take like the absolute value.
Mm-hmm. Okay.
So anybody want an answer?
I'm honestly confused. What do we have to do over here?
It's 1.95 into 10 raised to 6.
Yeah, there you are. Let's take a look at it here. Yeah, that basically is what you have to do. This, right? The electric potential energy equals to kinetic energy. If you solve for V final, this one is 2 times Q times the electric potential divided by the mass. Which 2 times, oh, let's remember this, 1.60 times 10 to the negative 19 multiplied by 20 kilovolts, which is 20 times 10 to the 3, divided by the mass, which is 1.67 times 10 to the negative 27 kilograms. Is there a question about this? On how I got this expression? No,
Could you
it's
please
just from
show
the
the
conservation
formulas?
method, right?
Could you
Huh?
please show the formulas we're applying and explain why do we apply them?
Yeah. So delta U is this formula. And this is just kinetic energy. So you're using conservation of energy because there is no other force acting. There's no friction for the proton. So it's being accelerated by this electric potential, which basically gives them energy, which is written like this, Q delta V, which converts into kinetic energy like this.
And then from this formula we find the final speed.
Yeah, due to the electric potential. Mhm.
Mm-hmm.
So negative 27, negative 19, that give you 8, 11, 12, square root, 10 to the 6. And then 2 times 1.6 times 2 divided by 1.7, 1.67, sorry. Where's my calculator? Here. 2 times 1.6 times 2 divided by 1.67, and then I take the square root, 1.95. 1.95 times this meters per second. As an advice, right? If you get a small value on the speed, like 10 to a negative, that's wrong. The proton or even an electron, due to an external electric potential or electric field, they will be accelerated to a very large value of speed. Why? Because they have a very small mass. That means they have a very large acceleration. All right? Just so you know. Any questions about this? This question, we did it in chapter 16. Assignment 2 should have or has questions about this. And those equations that we've been using, including capacitance, are here in these slides. So E equals to V over D, U equals to QV, energy conservation, remember we did it here, electric potential for a point charge, parallel plate capacitor, will you be able to go a small example? Oh, yeah, I don't know about that. C equals to Q over V, capacitance for a parallel plate capacitor, dielectric, so it's all here, chapter 16. All right. And then I want to go over this. I don't know if we have no time there is, it's just how. That's the only problem that I don't know how we can do this virtually, the Kirchhoffs. Um, yeah, I have to figure it out. In the meantime, I want you guys to do this.
Professor,
Yeah,
the pendulum type, the question, will it be in the exam?
what pendulum?
Like in the chapter, the first chapter, like there was a pendulum question. It was
No, no, like
rotating
I said,
on.
yeah, yeah, like I said at the beginning, that the concept you need to know, but a problem like that, no.
So, what's the direction of electric force in regard to electric field? Means it's opposite in the direction.
Okay, guys, do this while I answer his question. So this question, I want to see you guys can do it. So, okay. Uh, where's my thing here? So if you have a positive charge, right? The
Yes.
electric field at a given point, no charge in there, due to
Yeah.
Q is like this, away from the charge, because it's positive.
Hmm.
The electric field lines are always going like this, away. Okay?
Yeah.
If you have a negative charge, and the energy for the electric field at this point, the electric field will be towards the charge. Okay?
Okay. Mhm. Okay.
Okay, what about the problem 14?
We should use formula R equals resistivity times length divided by area, and then we'll have to find area to
You need
solve
to
it.
find resistance. Yeah, yeah. So you want to find the resistivity. Resistivity is just resistance times area over length. You
And the
have
area is PR squared, right?
is pi squared, yeah. And is it B? I think it's B, yeah. 0.25 times the area pi times radius diameter is 2, 1 times 10 to the negative 3, 1 times 10 to the negative 6. That's the area. Pi squared divided by the length, which is 20. 3.6. Yeah, let's see. 0.25 times pi divided by 20. Nice, A. 3.9 times 10 to the negative 8.
Yeah.
Guys, be careful with your calculations. Right? It's R divided by the area, which is pi squared, so times pi, divided by 20. So 0.039 times 10 to the negative 6. If I want 10 to the negative 8, I divide it by 100, multiply by 100 here, 3.9 times 10 to the negative 8. So the answer is A. And for the student asking for Kirchhoff, what is this? Kirchhoff. There's nothing here. Let's take a look. Sometimes they have something here. Ah, there you are. Okay, let's copy this. Okay, so how will you do this problem? We have 10 minutes. You're gonna find, and I wanna give you a few things because, yeah. So you're gonna find every current. Let's draw the currents here using this. So let's say you have a current like that. This is gonna be I1. I wanna draw I2 like this. Don't ask me why, I'm just gonna do it like that. And entering, leaving, and then let's make it leaving I3. There you are.
So I2 equals I1 plus I3?
Yeah, try to do that, bro. I give you, you got 10 minutes.
Okay.
Professor, you said I2 is equals to I1 plus I3, right?
Yeah, yeah, that will be the junction.
Yeah.
The review session has been recorded, so you guys can always go over it. On Wednesday, I should be in the school by 4:30. So if you guys have any questions, I will be in the lab MH161. And as you know, guys, the lab today is virtual, quite easy. If you ask me, like the equipment for resistivity is not the best. So you guys are actually gonna be doing the lab with very good results today. Doesn't matter. At least we didn't miss the parallel and series. That will be on Monday next week. So an idea that we were thinking with the faculty was to ask you guys to come on a spring break. But apparently you're not, there's some policy on campus. It doesn't allow us to do that. So that's why. So if you have a question, if you guys have equations, you can start typing them in the chat so I can double check what you have. The exam has 8 questions. I was gonna print it today, but have to print it, I think tomorrow. Uh, Staples. The schools are closed, even the high school is closed, so. What's MCQ? Oh, no, 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 no. They are all open-ended.
Professor, on the right side of this circuit, the 3 ohm resistor, what current is it related to?
What do you think? You should know. Let's look at the graph.
Is it I2?
Yep, it's I2.
Because
Mm-hmm.
I3 and I1 gonna unite at point F and then it's gonna give us I2, right?
Yeah, yeah,
Okay,
pretty much.
thank you.
Okay, so what equation you guys have? Come on. All right, there's one there. Now try to solve them. By the way, unrelated, but if you guys haven't cleaned your snow, you probably want to do it after class because I've been reading it's gonna get cold tomorrow and you don't want to wait until it's ice. I kind of did it already before class. So even though the schools are closed, a lot of things are gonna still be open tomorrow. I'm gonna be doing that tomorrow. No, 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 no. I'm not playing with that. I actually already. No, no, no. I don't even want to think about it.
We already received a message from college that on Wednesday the college is gonna be working.
Yeah, so are you freaking kidding me? If they cancel on Wednesday, I'm gonna snap. Like, I understand today, and we can do the lab online, you know, but no, no, no. Look, guys, I used to live in Canada for 4 years, and I went to school. I know it's not the same, but I went to school in a blizzard. So I don't think the school will do that. That's way too much. I don't even know why they're closing tomorrow. Like my driveway is clean. I'm gonna go to the gym tomorrow. I'm not gonna stay home. I'm gonna be bored here. What would you guys do? Seriously,
Go to the gym.
pretty much.
I mean, all the roads are cleaned by now.
Okay, so it's almost time. Let's say like the equations are Can you give us quick tips before and like what should we go over and what topics and what can we avoid? Avoid Gauss's law. The only thing. I won't be testing Gauss's law. And while we are in this meeting, the reason I do open-ended questions and not multiple choice is because I want to see how you guys do work. I'm one of the reasons why I feel students in the school don't do as good as they could is because all the exams that they take are multiple choice questions, and we don't really know if they know what they're doing, though, right? However, if I test you guys, you know, like that, then wow. So minus I frame. There you go. And of course, I2 equals to I1 plus I3. All right, guys. So I1 is 2, I2 negative 1.5, I3 negative 3 points. Is that what you guys got?
I think I got different answers. I probably did a mistake somewhere.
Oh, okay. Do I have to solve this? All right. Let's see. The thing is that this is gonna be harder to do here in the computer though. And I don't know where my marker is. Oh, here it is. Okay.
Professor, the first
Yep.
one is not 2i3, it's only i3.
Oh yeah, you're right. 3I1 minus I3. Right? And then
Yes.
9 equals to 5. Parenthesis I1 plus I3 because that's I2 plus I3. Six equals to 3I1 minus I3. 9 equals to 5I1
Were
plus
we
6,
solving counterclockwise or clockwise?
like this. Like this.
6. Then it should be
Then
6 minus 3i plus I3.
yeah, plus
If
I3. Yeah, that's what he told me, yeah. So this should be plus I3. Right?
Mhm.
And then 3I1 minus I3. Yeah, that's okay. So okay, let's quickly do this. 6, 18, 36, 45, 45, 18, 23. So what I get for I1 is I multiply the first equation by 6, so I cancel I3. So 6 times 6, 36, plus 9 is 45, divided by 18 plus 5 is 23. 1.6. Who got that? I1 is 1.6.
I did a mistake in the very beginning, so all my calculations are wrong.
Yeah, I think that's gonna be the issue, and that's why I have to do this open-ended. If I do a multiple choice, it will be horrendous. But at least like this, for example, the student got close actually here. He probably rounded it. You guys got the equations right though. So I1 is 1.6, 4.8, 1.2. I3 is 1.2. It's negative 1.2. Yeah. So that means
Professor.
that I3 is in the opposite direction. So I3, ay caramba. Yeah. I3 is negative 1.2 based on this equation here. I need to send this to the lab as well. Sorry guys, you can stay here. I'm gonna just send the link to the students in the lab. Pseudo. Let's check my
Sir,
screen
I had
again.
a question.
Yeah.
Oh, isn't it supposed to be -6 and -9? Because they're going in the same direction. And I remember you saying if there's going in the same direction, there's a voltage drop, which means it's going to be negative.
For voltages, let me see.
Yeah, the voltages.
Because if your loop goes on the same direction as the negative to positive, sorry, I have to do this. You don't have to leave, guys, because we're still doing this, all right? Oh, damn it, I erased it. Okay, so let's go over this, all right? So we did it like this, right?
Yeah.
So positive, because you're going from negative to positive. So it's 6 positive. It's fine.
Oh, okay.
And the current, I gave the currents like this, right? I1, I1, I1.
Oh, okay.
And then what was I2? I2 was like this, right?
Yeah.
Yeah,
Yeah.
I2. And then I3 was like this.
At 1 ohm. Yeah.
Like this, I think.
Yeah, it was like that.
Okay, I3. Admit it. So yeah, these are the equations for the loop. And yeah, I2, this I2 is equal to I1 plus I3. Yeah, leaving and entering. Is that clear
Oh,
for everybody?
okay, so if you switched, like, let's say you made it clockwise, going from positive to
Yeah.
negative, which means the 6 would be
If you did,
negative then.
yeah.
Okay. Okay. Yeah, that's where I got it
Yeah.
wrong.
But come on, guys, I know there's more questions here. Did everybody get this? Like the main thing I want to ask is this: did everybody get
Wait,
these
I have a
equations?
question.
It's the main thing. Yeah.
So in the exam, are you gonna give us like the arrows, like the way you just did here? All we have to figure out is to do clockwise or counterclockwise, correct?
Yes, yeah. The currents will be given to you.
Okay.
The currents will be given to you. Okay, so another question here. Can you explain when we are? Okay. So by the way, guys, the students that just came, I'm gonna start the lab in 5 minutes. Just stay there. You can listen if you want. That's fine. It all comes with a math. So you see, I rearrange my first equation like this. Right? And then the second equation is like this. So I don't know if they told you this in algebra. Always keep the coefficients positive. That's why I tell my math students in the school. Always keep your coefficients positive. Why? Because that negative may trigger a mistake when you're doing equations or quadratics, right? So keep them positive like that. And the constants, try to keep them positive, like the 6 and the 9. So that's why I rearrange it like that. Then if you look at the junction rule, I2 is equal to I1 plus I3. So this goes there. Why am I doing that? Because I have this 1 and I3. So then I need a second equation to have I1 and I3. I already have I3 here, so I2 is I1 plus I3. So conveniently, I substitute it in the second equation. That's why you end up getting this. 6 equals to 3I1 minus I3. Man, that many students? Okay. And then on the second equation, you get 9 equals to, well, 5I1 by itself plus 5I3 plus I3 plus 6i free. So now I have these equations here. Let's write them properly. Wait, here. 6 equals to 3i1 minus I free. And 9 equals to 5i1 plus 6i free. Pretty obvious which variable I have to eliminate. I eliminate I free because it's negative here, positive on the bottom, so I multiply the first equation by 6. And that's how I got I1 equals to 1.6.
We'll multiply the top by 6, you said, right?
Yeah. Again, that's just math. Once you have the free equations, is your algebra, what's this? Algebra 1, algebra 2, right? Your free by frees. It's just any method. You can use substitution, you can use elimination, you can use matrices if you want, but I don't think you need to do that for this.
And what is going to be I1 equal to?
I got 1.6.
1.6?
Yeah,
So we
yeah.
multiply the top by 6. It's going to be 36 equals 18 I1. Then we have to add, we cancel the negative and positive I3s. And then it's going to be 36 plus 9, it's going to be equal to 45, equals 18 plus 5, it's going to be
23.
23. And then we divide 45 by 23.
It's 1.6.
I get 1.95. Am I tweaking?
What? Really?
45 divided by 23? Yeah, 1.95.
Oh, yeah, my bad. It was 28 here. It's 23. Yeah, my bad. So 45 divided by 23. Yeah. Yeah, 1.95. 1.96. Yeah.
Okay.
And then I free will be -0.12, negative 0.12. Yeah, negative 0.12. All right, guys, 7:10. I have to start with the lab. Any other questions before we finish? I'm going to start the recording now.